Welcome back everyone. Now we are going to learn about the program status word, and in that we have two things, CISC and RISC, that we are going to discuss in detail. So let's first start with the program status word. So what is the program status word indeed? Well, program status word is a collection of all status bits. Surely we are going to work on the bits in the CPU. So that's the keyword here that we have, program status word. So program status word is actually the collection of all status status bits, you can say, in the CPU. Like you are able to see that 80% complete, 90% complete, and then it 100% gets completed. So these kind of the statuses that we have, well, you can assume it at the program status word for the CPU. So PSW, I mean with program status word, PSW is a separate hardware. It's stored in a separate hardware. Why it's in the separate hardware? Well, I asked myself when I studied it first. So this is because we need to keep the status from outside. How can you take the status living inside of something? So we need to keep the status from outside. So the status is looked from the outside. If you think it clearly, always there is an outside person, a senior, a teacher, a HR, or someone who takes the thing from outside. So this requires a separate hardware which takes the information outside. Well, we can say hardware register, as we are studying the register extensively from the last section. So I'm adding the register word here also. It always means just to keeping that information. It contains the information about CPU. It contains the information about CPU. But you can consider it in points. So it stores separate hardware register, uh, stores stored in separate hardware register. It contains the information about the CPU, like your CPU is used 50%, 80%, 20%, 90%, whichever the percentage we have gone through. So there are two modes that I would like to discuss here. First is called as separate mode. So in the separate mode, what we have here is something like this. Well, when a CPU is executing a program, CPU is executing a program, that is the part of operating system, that is a part of operating system, our OS, like Windows, Linux, Mac, or Android, or whatever the software is. So that is the separate mode. And what's the another thing that I would like to mention here? Well, the another thing is user mode. So as the name suggests that a user is here, well, technically, right? A user has to be here in the user mode, obviously. Okay, so all programs that run by user, well, very simple. All program that is run by user, run by user. Like I am using a program that can store and I can write on that. Well, that's my pad thing. So that is a kind of the program that allow me to write and speak at the same time. Or you can take it as the doc file, you can take it as a PDF file, you can take it as something you can interact with, that kind of program, and you can run. Like the spreadsheets are the most common example, the PowerPoint presentations are the example. So these are the programs that you can run and work upon. An important aspect of the computer architecture is design of the instruction set for processor. The instruction set chosen for a particular computer determines the way chosen for a machine language program are constructed basically, and we have two instruction sets. So as I mentioned here, we have two instruction sets here. So you can call them instruction set. I just don't written it there already. These are the instruction sets, and this is going to decide that how a machine is actually going to work and which kind of the programming languages it's going to support, which version it's going to support. These all the things are dependent upon its versions, and for right now we have CISC and RISC. So let's study it in detail about the CISC and RISC. So CISC, and here we have RISC. So let's study that in the differentiated form so that we can understand the things and compare along the side that what is what and what it means. So first of all, let's begin with the full forms. So the CISC means complex instruction, complex instruction set architecture, set architecture. So complex instruction set architecture, and RISC means reduced instruction, reduced instruction set computer. Well, I should not write the architecture here, I should write the computer here instead. Computer, because we are studying about the full form. So these are the two kind of the computers. You have to understand that we are studying the CPU in a detailed way, and CISC kind of the CPU exists and RISC do exist. Both have its own advantages and disadvantages surely. That's why we are using two different things. As the first thing is suggesting, CISC is used as a complex instruction and RISC is reduced instruction. So let's study more things. In CISC, we have large number of instruction, large number of instructions uh, from 100 to 250 instructions. 100 to 250 instructions. And in the RISC world, we are having relatively few instructions. Well, I'm not writing that how much few, but you can understand that relatively few means definitely less than 100. Relatively few instructions. So that seems a negative point for the RISC, and till this point CISC seems to be winning. Some instructions performed in CISC perform the specialized tasks. So specialized tasks, and air is used infrequently, and it's used infrequently. Well, I'm not mentioning it right here, it's just for the specialized task. And for this one, it is having relatively few addressing modes. relatively Relatively few addressing modes. Addressing modes. So surely you can guess that it is having more addressing modes, more addressing mode. That makes it more specialized for every other task. More addressing mode. So till even this point, we feel like CISC is larger thing, something larger. Well, let me also mention that how many addressing modes we can expect. It's 5 to 20. So that's why it can have specialized thing for each of the instruction. Now the variable length of instruction format, we have here variable length for instruction format. like we can have it 2 bit, 3 bit, 100 bit, or whatever bit we like to call it. So it is having variable. It can vary as according to our need. So what in the RISC you can assume it is having memory access limit. It is having memory access limit. Well, it seems like a disadvantage, but let me mention something that it will seem apparently seeming the advantage of RISC. Yes, you have heard me right. Because of the variable length, you don't know, you don't think to fit everything into smaller space. You just take, even if it takes 2 GB, you are going to be ready for the 2 GB of the instructions. But in RISC, we try every possible way to hold the instruction in a definite limit. So memory access is limited to to store and load instructions. So definitely RISC is having some smart ways, not in all the cases of course, but mostly a smart way that can solve the problem and can do not need, and is it's not in the need of the variable length. It fits everything in the same space. So I can say the RISC designers work really hard to fit in the things. And now the next point that I would like to mention here in our thing, okay, let's, okay, give me 1 second. I just lost my sheet. Okay, no matter. We will fit everything right here. Okay, got it. Now, um, CISC here and RISC here. So, what else we can expect from here? Well, in the CISC we have instruction that manipulates instructions that manipulate or manipulate, whichever way you like to pronounce it, manipulate, manipulates actually, operands in memory, operands in memory. And in the RISC, we have all operations done, all operations done within the register of CPU. So if you will give CPU some more space, it will solve everything at once. So this is the advantage of RISC. And now let's study more points on this. Well, let me mention the RISC advantages, as we have continuously been saying that CISC, CISC, CISC. So let's now say RISC, RISC, RISC. So it is having fixed length, and it was having the variable length, as you have remembered that I have mentioned it earlier also. So it is having variable length for the instruction. Now it is having fixed length, easily decodable. That's the kind of thing that I was talking about, that it is going to take longer time, longer because you are allowing how much space you want, you can have it, and this is a smart way. So length is easily decodable instruction set, we are having it here. Okay, now the next point is single cycle instruction execution. Means once you start, it will come up with the finished result. Well, it's like me. Once I start, I leave the lesson once it's finished most of the times. But it is having multi-cycle instruction. And what else we are having here? It is hardwired, then micro-programmed, micro-programmed control. This is not. So that's the whole thing. I will explain the hardware in a detail in just a while. Now let's see that on the previous page we have mostly seen the CISC advantages and RISC disadvantages. But in the next page, RISC became our hero and CISC is not that much worthy. So this is how the world happens. This is how the RISC and CISC things are there. So let's have you talk on the CISC. Well, a computer with large number of instruction set is called complex instruction set. Well, surely CISC. The essential goal of CISC architecture is to attempt to provide a single machine instruction for each statement written in high level programming language, and that is its disadvantage too, because it wants to solve everything, so it makes a separate thing for each of the problem. Well, that can be a solution, but you don't know that how many problems are going to occur, and you are going to give the space for every of the problem, and you are going to solve every of the thing together, then you are going to get the result. But RISC, in the RISC, in this concept, architecture involved as attempt to reduce the execution time. Well, that's a smart way. Reduce the execution time by simplifying the instruction set of computer. In the RISC instruction set, we have few instructions to reduce because we have already just having less memory, and as well as overhead to member of instruction. It's easy to decode because we have a limited amount that we need to decode. Like if you are speaking in the English language and maybe we have to translate it, so in the English letter we have just 26 letters that we need to decode. But if you are talking in the Hindi language, you are having 56 letter. If you are talking in the Chinese, you are having more. If you are talking in the Japanese, you may have more. So these are the kind of the things that more and less kind of the work is going on. Well, it seems like I'm promoting RISC, but let me tell you something. I am operating right now on my CISC computer, and I am saying and bragging about the RISC. Well, that's completely being a choice because this is being researched, and there is so many people actually who are in the support of CISC. There are so many people who are working day and night to make the RISC better. Few people think that you can solve it in the CISC way. Few people think that we can solve it in RISC way. So this all the things happen. It has not solved yet, so that I can declare one as a winner. That's why I try to mention the CISC and RISC in the separate formats. Well, let me also tell you that where RISC lags, because RISC seems every way it seems like it is having the advantage. So why not everything is in the form of RISC, and why is the CISC popular, so much popular? Well, let me tell you that if you try to decode everything with a limited amount of the memory, you are not actually allowing more things to come in. That's the most important factor. CISC allow everything to come in, but RISC don't allow it. That's the most important aspect. I will not call it disadvantage, but I will call it as the aspect of RISC that is being solved in the CISC already from its very basic fundamentals. So that's all about the RISC and CISC, and we will learn that what are the hardware control in the next one along with the control unit. So till that time, take care, God bless, and keep on learning and pondering. Sayonara, take care, namaste.